Good afternoon, dear students. So today we will study the second chapter, that is electric potential and capacitances. Already we completed first chapter, that is electric charges and electric field. Electric charges numerical also completed, electric field numericals. So 4 I have completed. Still I think 15 to 20 problems are there that we will send every day evening session. Okay, today let us start the second chapter, electric potential and charges. So the total teaching hours for this chapter is 9 and total marks is 8. So what kind of questions appear from this chapter, that we will see. So there are two options actually. 1 mark question 1, so 1 mark. 2 mark question is also 1, that is 2 marks. 5 marks theory is there, that is 1, so 5. So total how many marks? 8 marks. The teaching hour is 9 and total marks if you study this chapter is 8. So this is not always the questions that appear in the annual exam. So the question may appear like this also. So here no 1 mark question, no 2 mark question, but 3 mark question will be 1. 3 into 1, 3. 5 marks, here theory, here what? Problem. If problem is there from second chapter, then theory will be there from first chapter, 5 marks theory. So 5 marks problem 1, that is 5, 3 plus 5 how much? 8 marks. So if you study in detail the second chapter, so you will get how many marks? 8 marks. So okay, so let us start. Here also there are two concepts. In the first chapter also two concepts we studied. One is electric charge, another concept is what? Electric field. So in this chapter also there are two concepts. One is electric potential and the other one is capacitances. Capacitances means what? Here is one device. Capacitor is one device. We are going to measure the ability of that device, which is called as what? Capacitance. So that is another session. So first we will study what? Electric potential. So in Latin potential means energy. Potential meaning energy. So electric potential. Electric means it is a charge. Energy of charge is nothing but what? Electric potential. So the amount of energy present in the charge when it is there in electric field. See, no doubt the charge produces electric field around it. So that is the entire concept. If one charge is kept in an electric field, if it possesses energy, if it has energy, then the energy of the charge in an electric field itself is what? Electric potential. So in first year we studied work, power and energy. Work energy theorem, V theorem we studied. V theorem. What is this V theorem? Work, W stands for work and E stands for energy. So ಎರಡು ಏನಂದ್ರೆ ಒಂದಕ್ಕೊಂದು related. If you do work, it gets converted into energy. If you have energy, then we can do work. So work and energy, they are not separate quantities, they depend on one another. Energy is nothing but work, work is nothing but what? Energy. So what is energy? The ability of an object, the capacity of an object to do work is called as what? Energy. What is work? If force applied on any object, if it shows displacement in any direction except in perpendicular direction, then work is said to be done. So if you want to do work, we should have what? Energy. So energy is nothing but work. So there are two concepts we studied. Work done is nothing but change in potential energy. Similarly, work done is nothing but what? Change in kinetic energy. So due to motion body may have what? May acquire what? Energy. That energy is called as kinetic energy. And due to this kinetic energy, we can do work. So due to position or change in configuration, the object may acquire energy. That energy is called as potential energy. Due to potential energy also, the object will get the capacity to do some work. So both are dependent. See here what we are going to study: electric potential. Electric means it is charge. Potential means energy. The energy of charge we are going to study. When charge acquires energy. So that is what we are going to discuss in detail about electric potential. So tomorrow I will upload the notes on the second chapter. So we all know that charge produces electric field around it. See, this is what the electric field produced by some source charge. Okay. Source charge is represented as Q. So around this charge there is what? Electric field. This is the region of electric field. Imagine, just to convince you people, I have drawn certain area around this source charge. Now one more charge, test charge. What is test charge? Unit positive charge. Its magnitude is 1. It also have electric field around it, but the intensity of electric field produced by test charge is much smaller than the intensity of electric field produced by source charge. Means the electric field of test charge does not affect the electric field of the source charge. Okay, I take unit positive charge or test charge somewhere here at infinity. I take this is what? Test charge Q0, which is at infinity. See, here source charge is also positive and test charge is also positive. That's why one more name of unit test charge is what? Unit positive charge. Unit is what? 1 magnitude. Positive is nature of test charge. Now, what I want to do is, I bring this test charge from infinity. So here I choose one point in an electric field, somewhere here. Somewhere here I choose one point. I want to bring that unit positive charge from infinity to this point. So I'll start moving or bringing that unit positive charge to the point in an electric field. So there is no any opposition, any kind of opposition, because that test charge does not experience any electric force. What is electric force? The force experienced by electric charge in an electric field is called as electric force. So when that test charge is out of this electric field, then it does not experience any electric force. If no force, no work done. So we can bring that test charge around from that infinity up to here. Once this test charge enters the electric field, so here the test charge entered the electric field, then it starts experiencing electric force which is repulsive. Why it is repulsive? Because test charge is also positive and source charge is also positive, like charges repel. We are bringing that test charge to this point. But when that test charge enters the electric field, it experiences repulsive force. Then we have to overcome that repulsive force and we have to bring that test charge from infinity to this point. So means to bring that test charge from infinity to this point, here we have done work against the electric field. So as this is a positive source charge, so electric field is away. and we are bringing against the electric field. So we have to do work. So that work done is stored as energy in electric charge. That energy itself is called as electric potential. So ಅದಕ್ಕೆ ನಾನು ಏನು ಹೇಳಿದ್ದೆ ಅಂದ್ರೆ ವರ್ಕ್ ಎನರ್ಜಿ ಥಿಯರಮ್ ಹೇಳಿದ್ದೀನಿ ನಾನು. ವರ್ಕ್ ಮಾಡಿದ್ರೆ ಎನರ್ಜಿ ಕನ್ವರ್ಟ್ ಆಗ್ತದೆ, ಎನರ್ಜಿ ಇತ್ತು ಅಂದ್ರೆ ವರ್ಕ್ ಮಾಡ್ತೀವಿ. So work done is always converted into energy. So here where we have done the work, so when the test charge is inside the electric field, we have done the work. When electric charge is outside the electric field, then there is no repulsive force, then there is no opposition. So that test charge is brought from infinity to this point without any doing work. Once the test charge enters the electric field, it starts experiencing repulsive force. So to overcome that repulsive force, we have to do work. That work done is stored as energy in an electric charge. That energy itself is called as electric potential. So electric potential is nothing but what? Work done. Then how to define electric potential? So define means we should write answer using the formula. So then what is electric potential? So what you have done? So what we are doing actually here, we are bringing test charge from infinity to one point in an electric field. To bring that test charge from infinity to this point, we have to do work. That work done is called as electric potential. See how to write what is electric potential. The work done in bringing unit positive charge from infinity. Infinity is very important because we can move charge from this point to this point also. So this is not infinity. So this is what infinity we call. That's why infinity is very important. So what we are doing? We are doing work. For what we are doing work? To bring test charge from infinity. Where we are bringing that? To one point in an electric field. So the work done in bringing unit positive charge, or we can call it as what? A test charge also. The work done in bringing test charge from infinity to a point in an electric field. See, concentrate on the sentence. Now ಏನು ಮಾಡುತ್ತೀವಿ? ಆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ನ ನಾವು ಎಲ್ಲಿ ತೊಗೊಂಬಂದಿಡಕತ್ತಿದ್ದೀವಿ? ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ದಾಗ ಒಂದು ಪಾಯಿಂಟ್ ಚೂಸ್ ಮಾಡಿದ್ವಿ, ಆ ಪಾಯಿಂಟ್ನಾಗ ತಂದು ಇಡಕತ್ತ. ಆರಾಮ್ಸೆ ಅದನ್ನು ಹೋಗಿ ತಂದು ಹಿಂಗೆ ಇಡಕ್ಕಾಗಂಗಿಲ್ಲ. ಯಾಕಂದ್ರೆ ಅದನ್ನು ತೊಗೊಂಡು ಬರಬೇಕಾದ್ರೆ ಯಾವಾಗ ಅದು ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಎಂಟರ್ ಆಗ್ತದೆ, ಇಟ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್. ಆ ರಿಪಲ್ಸಿವ್ ನಾವು ಅದನ್ನು ಒಳಗೆ ತರಕ್ಕೆ ನೋಡ್ತೀವಿ, ಇದೇನಾಗುತ್ತೆ ಹೊರಗೆ ಹೋಗಕ್ಕೆ ನೋಡ್ತೀವಿ. ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಅದನ್ನ ಏನು ಮಾಡ್ತೈತಿ? ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ದಿಂದ ಹೊರಗೆ ನುಗ್ಸಾಕ್ತೈತಿ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಆ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಓವರ್ಕಮ್ ಮಾಡಬೇಕಂದ್ರೆ ವರ್ಕ್ ಮಾಡಬೇಕು. ದಟ್ ವರ್ಕ್ ಡನ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ವಾಟ್? ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್. ಸೊ ಅದಕ್ಕೆ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂದರೆ ಏನು ಹೇಳಿ ನಾನು? ಎನರ್ಜಿ ಅಂತ ಹೇಳಿ. ಇಟ್ ಈಸ್ ಅ ಕೆಪಾಸಿಟಿ ಆರ್ ಎಬಿಲಿಟಿ ಅಂತ ಹೇಳ್ಬೋದು. ಐ ಹೋಪ್ ಯು ಆರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ಎಲ್ಲೋ ಇನ್ಫಿನಿಟಿ ಒಳಗೆ ಒಂದು ಚಾರ್ಜ್ ಐತಿ, ಆ ಚಾರ್ಜನ್ನ ನಾವು ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ನಾಗ ತಂದು ಇಡಬೇಕಾಗೈತಿ. ತಂದು ಇಡಬೇಕಂದ್ರೆ ವರ್ಕ್ ಮಾಡಬೇಕು. ಆ ವರ್ಕ್ ಮಾಡುವಂಥ ಕೆಪಾಸಿಟಿಗೆ ಅಥವಾ ಎಬಿಲಿಟಿಗೆ ಏನಂತ ನಾವು electric potential ಅಂತ ಹೇಳಬಹುದು. Okay. So what is electric potential? The work done in bringing test charge from infinity. Infinity you must and should write. From infinity to a point in an electric field is called as electric potential. So I write question over here. What is question? What is electric potential? Electric potential. Okay, it is work done. Work done to bring unit positive charge from infinity to point in an electric field. Infinity ಒಂದು ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಐತೆ, ಅದನ್ನ ಎಲ್ಲಿ ತಂದಿಡ್ತೀವಿ? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ನಾಗ ತಂದಿಡ್ತೀವಿ. ತಂದು ಇಡಬೇಕಂದ್ರೆ ಕೆಲಸ ಮಾಡಬೇಕು. ಆ ಮಾಡಿದ ಕೆಲಸಕ್ಕೆ ನಾವು ಏನನ್ನಾಗತ್ತಿದ್ದೀವಿ? ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂತ ಹೇಳತ್ತೀವಿ. ಇಟ್ ಈಸ್ ದ ವರ್ಕ್ ಡನ್ charge, ನಿಮಗೆ ಇದು ಭಾಳ ಡಿಫಿಕಲ್ಟ್ ಅನ್ಸಕತ್ತಂದ್ರೆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್. In bringing test charge from infinity to a point in an electric field. In an electric field is called as electric potential. ಇಲ್ಲಿ is called as ಬರೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. So directly this sentence ಮುಗಿತದೆ. What is electric potential? It is the work done in bringing test charge from infinity to a point in an electric field. Okay. ಇನ್ನು ಇದಕ್ಕೆ symbol ಏನು? Symbol V. Capital V we should write as a symbol. We will write formula. Electric potential or simply potential also we can call. Electric potential is equal to work divided by charge. Work done divided by charge. Work done in moving charge from infinity to a point in an electric. Symbolically we write V equal to W divided by QZ. So in general we can write Q also. Okay. So on this equation we will define the electric potential. So define electric potential. What is ಅಂತ ಕೇಳಿದಾಗ ಅದನ್ನ ಬರೀರಿ. Define ಅಂತ ಕೇಳಿದಾಗ ಇದನ್ನ ಬರೀಬೇಡ್ರಿ. Define is always written using the equation, using the formula. Define electric potential. It is the ratio of ಹಿಂಗ್ ಬಂತಂದ್ರೆ ಏನು ತಗೋತೀವಿ ನಾವು ನ್ಯೂಮರೇಟರ್ ಡಿನಾಮಿನೇಟರ್ ಕಾನ್ಸೆಪ್ಟ್ ನಾಗ ಬಂತಂದ್ರೆ ರೇಷಿಯೋ ಅಂತ ಹೇಳ್ತೀವಿ. It is the ratio of work done in bringing unit positive charge from infinity to a point in an electric field. Adu what is that? It is the ratio of work done to charge, or it is the ratio between work done and charge. It is the ratio of work done to move a charge from infinity to a point in an electric field. Now we will write, once we write the formula, next what we have to write? We have to write units, dimensional formula, nature, either scalar or vector, direction, so etc we should write. So now we will write units. First one is SI unit. SI unit of electric potential. Work is joule, charge is coulomb. Joules per coulomb. MKS unit, volt. Actually this is not pure SI unit. It is not pure SI unit. Pure SI unit, see. Work done kg square meter per square second, coulomb ampere second. So write in one line kg square meter. Here nothing means 1. If it goes to the numerator -1, -1 -2, it is -3, 8 raised to -1. So purely we will write SI unit kg square meter per cubic second per ampere. and MKS unit is volt. So here you can write joule per coulomb also. This is a MKS and the SI both are same only. Volt, its symbol is V. Okay, 1 volt equal to, we can write 1 joule per coulomb. So now define volt, or when electric potential is said to be 1 volt. Okay, here only I take a question. Define volt, or when electric potential is said to be 1 volt. Okay. V equal to W divided by C. V 1 volt, 1 joule, 1 coulomb. If we do 1 joule of work in bringing 1 coulomb of charge from A to A, from infinity to a point in an electric field, then 1 joule work ಮಾಡಿದ್ದು ಅಂತ ಎದಕ್ಕೆ ವರ್ಕ್ ಮಾಡೋರು ನೀವು 1 coulomb of charge ನ ಇನ್ಫಿನಿಟಿ ದಿಂದ ಎಲ್ಲಿ ತಗೊಂಬರ್ತೀರಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ತಗೊಂಬರ್ತೀರಿ 1 coulomb of charge ನ ಇನ್ಫಿನಿಟಿ ದಿಂದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ತಂದಿಟ್ಟು ಅಂದ್ರೆ ಅವಾಗ ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಬೇಕಾಗ್ತತಿ 1 joule ವರ್ಕ್ ಮಾಡಬೇಕಾಗ್ತತಿ so if 1 joule of work is done in bringing 1 coulomb of charge from infinity to a point in an electric field, then electric potential is said to be 1 volt. ವರ್ಕ್ ಇಟ್ಟ 1 joule, ಎಷ್ಟು ಚಾರ್ಜ್ 1 coulomb, ಎಲ್ಲಿಂದ ಇನ್ಫಿನಿಟಿ ದಿಂದ ಎಲ್ಲಿಗೆ ತರಬೇಕು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ತಗೊಂಡ್ಬರ್ಬೇಕು. ಇಷ್ಟು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. If 1 joule of work is done in bringing 1 coulomb of charge from infinity to a point in an electric field, then electric potential is said to be 1 volt. Then electric potential is said to be 1 volt. So this is how to define volt. Okay. Now this is about units. We will write dimension formula. Dimension formula is written on this your essay. Okay. Dimension formula. kg means mass, meter means length, 2, second means time, minus 3, A stands for ampere current, minus. This is dimension. Nature, it is scalar, work is scalar, it has no any particular direction. So it is scalar quantity. Nature, it is a scalar quantity. So no direction. This is about electric potential. Simple concepts are ಚಾರ್ಜ್ ನಾವು ಏನು ಮಾಡಬೇಕಾಗೈತಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ನಾಗ ತೊಗೊಂಡು ಬಂದು ಇರಬೇಕಾಗೈತಿ. ಅವಾಗ ಏನು ಮಾಡ್ತೈತಿ ವರ್ಕ್ ಮಾಡ್ತದೆ. ದಟ್ ವರ್ಕ್ ಈಸ್ ಸ್ಟೋರ್ಡ್ ಆಸ್ ಎನರ್ಜಿ ಇನ್ an electric charge. So the energy of electric charge itself is called as electric potential. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಚಾರ್ಜ್ದ ಎನರ್ಜಿ ಏನಂತೆ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್. ಚಾರ್ಜ್ದಾಗ ಎನರ್ಜಿ ಬರಬೇಕಂದ್ರೆ ನಾವು ಏನು ಮಾಡಬೇಕು ವರ್ಕ್ ಮಾಡಬೇಕು. So that energy is stored. So first year the work energy theorem you studied in detail. If you have any questions regarding that work energy theorem, you just comment, we'll answer it. So electric potential, what is electric potential? It is the work done in bringing test charge from infinity to a point in an electric field. Symbol is V. Formula electric potential is equal to work done divided by charge. This is symbolic. And defined electric potential. If you write equation, then you can write the definition. It is the ratio of work done to move a charge from infinity to a point in an electric. Next we have written what? Units. SI unit is kg square meter per cubic second per ampere, or you can write just joule per coulomb. MK is volt. What is SI unit of electric potential? Any three you can write. Any three you write. So this is most simple. Next, when electric potential is said to be 1 volt. So work and charge is there. How much work? 1 joule of work to bring what? 1 coulomb of charge from infinity to a point in an electric field. Then electric potential is said to be 1 volt. Dimensional formula we have written, and then nature it is scalar, it has no direction like electric field. Okay. Next concept, potential difference. Potential only, but difference. Potential difference, energy difference. So, my energy is different, your energy is different. Each and every person is having different amount of energy. So, like that. So, charge, we will bring charges from infinity to different points in an electric field. Then, the energy of those different charges is also different. There will be difference in energy. The difference in energy itself is called as potential difference. Potential difference. In short, we can write P dot D. Okay, before this potential difference, let me check your presence of mind. This is the electric field. I chose 2 points in an electric field. This is first point and this is second point. Somewhere here source charge is there, Q. Okay, this is second point. 2 points are located in an electric field from this source charge. So 2 is nearer to the source charge and 1 is little away from the charge. So I call this distance as D1 and this distance as D2. Okay. So now I'll bring the test charge Q0. I bring the test charge Q0 from infinity to a point 1. Here the work done is W1. So the same test charge, if I bring from infinity to this second point, ಮೊದಲ ಏನು ಮಾಡಿದ್ನಿ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ನ 1 ಪಾಯಿಂಟ್ ತಂದಿದ್ನಿ ಅಲ್ಲಿ ವರ್ಕ್ ಡನ್ ಏನಾಯ್ತು W1 ಆಯಿತು. ಇನ್ನೊಮ್ಮೆ ಏನು ಮಾಡ್ತೀನಿ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಇನ್ಫಿನಿಟಿದಿಂದ ಎಲ್ಲಿ ತೊಗೊಂಬರಾಕತ್ತಿದ್ದೀನಿ ಈ ಅನ್ಕತನ ಇದನ್ನು ತೆಗೆದುಬಿಡ್ತೀನಿ ನಾನು, ಕನ್ಫ್ಯೂಷನ್ ಆಗೋದು ಬೇಡ. ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಇಲ್ಲೈತಿ, ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ಇಲ್ಲೈತಿ. ಇನ್ಫಿನಿಟಿದಿಂದ ಒಮ್ಮೆ ಫಸ್ಟ್ ಪಾಯಿಂಟಿಗೆ ತೊಗೊಂಬನ್ನಿ ವರ್ಕ್ ಡನ್ ಇಸ್ W1 ಅಂತಂದು, ಇನ್ನೊಮ್ಮೆ ಇನ್ಫಿನಿಟಿದಿಂದ 2 ತೊಗೊಂಬನ್ನಿ ಅಲ್ಲಿ ವರ್ಕ್ ಡನ್ ಏನೈತೆ ಹೇಳ್ರಿ W2 ಅಂತ. So here W1 W2 same ಆಯಿತು and different ಆಯಿತು. The work done in bringing Q0 from infinity to first point is W1. Similarly, the work done in bringing test charge from infinity to second point is W2. Here the work done is same or different? You only tell. So work is considered when the test charge enters the electric field. So electric field ಇಂದ ಹೊರಗಿದ್ದಾಗ ಅದು ಬರಂಗಿಲ್ಲ, ಅಲ್ಲಿ ನಾವು ವರ್ಕ್ ಮಾಡಕತ್ತೀವಿ. ವರ್ಕ್ ಯಾವಾಗ ಮಾಡ್ತೀವಿ? when the charge experiences repulsive force. To overcome that repulsive force we have to spend our energy to do work. ನಮ್ದ ಎನರ್ಜಿ ಮೆಕ್ಯಾನಿಕಲ್ ವರ್ಕ್ ಆಗ್ತೈತಿ, ಅದ ವರ್ಕ್ ಏನಾಗ್ತದೆ ಹೇಳ್ರಿ ಎನರ್ಜಿ ಆಗಿ ಸ್ಟೋರ್ ಆಗ್ತದೆ. ಅಂದ್ರೆ ನಮ್ದು ಎನರ್ಜಿ ಎದ್ರ ಒಳಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತದೆ, ಈಗ ಚಾರ್ಜ್ ಒಳಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತದೆ. ಸೊ ಎನರ್ಜಿ ಕ್ಯಾನ್ neither be created nor be destroyed, but it can be transferred from one place to another place in different forms. Okay. ಸೊ ಈಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ನಾಗ ಇಷ್ಟ ಡಿಸ್ಟೆನ್ಸ್ ಮೂವ್ ಆಗೈತಿ, ಇದು ಇಷ್ಟಕ್ಕೊಂದು ಡಿಸ್ಟೆನ್ಸ್ ಮೂವ್ ಆಗೈತಿ ನೋಡಿ. So this distance is less, this distance is more. Here work is less, here work is more. So W1 is less than W2. More work is done here, less work is done here. Means here energy stored is different, here energy stored is different. So there is the difference in potential. Here potential is different, here electric potential is different. Here electric potential is 1, here electric potential is 2. Because work done W2 is greater, W1 is smaller. Therefore energy stored more here, less here. So more energy, less potential, more potential. There is a difference in potential. So that is called as potential difference. So here the energy is different, here the energy is different. Here the potential is V1, here the potential is V2. Potential V1 is less than potential V2. Therefore, in an electric field, the potential is different at different points. So there is always difference in potential, that is called potential difference. Okay. I hope you understood this concept. Now, potential difference. ಹೆಂಗೆ ಅದನ್ನು ಬರೆಯೋದು? ವಾಟ್ ಈಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಂತ ಕೇಳಿದ್ರು ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಅಥವಾ ಡಿಫೈನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಂದಾಗ ಹೆಂಗೆ ಬರೆಯೋದು? ಯು ಕೆನಾಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಬೈ ಟೇಕಿಂಗ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಫ್ರಮ್ ಇನ್ಫಿನಿಟಿ. ಹಿಯರ್ ಇನ್ಫಿನಿಟಿ ಈಸ್ ನೋ ಫೈನೈಟ್ ಡಿಸ್ಟೆನ್ಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್. Potential difference comes within the electric field. Okay. Suppose this is electric field. This is one point, this is another point. Here this I call as A, this I call as ಅಥವಾ ಇದಕ್ಕೆ A ಅಂತೀನಿ, ಇದಕ್ಕೆ ಏನು ಅಂತೀನಿ, B ಅಂತೀನಿ. ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಎಲ್ಲೈತಿ Q0 ದಾಗ. ಸೊ ಅವಾಗ ಇದ್ರ ಪೊಟೆನ್ಷಿಯಲ್ ಏನೈತಿ VA, ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಏನಂತ ಹೇಳಿದ್ರೆ VB ಆಗ್ತದೆ. Here VB is greater than VA, remember. Now I bring, this is finite distance. The distance between the 2 points A and B is D. Okay, finite distance. It's not infinite. So again we will bring this unit positive charge from A to B. It is not so easy to bring this Q0 from A to B. Again we have to do work here. So the work done in moving unit positive charge from one point to another point in electric. Infinity use ಮಾಡೋಂಗಿಲ್ಲ. Electric field ಒಳಗಡೆ ನಾವು ಎರಡು ಪಾಯಿಂಟ್ ಏನು ಮಾಡ್ತೀವಿ, ಚೂಸ್ ಮಾಡ್ತೀವಿ. ಚೂಸ್ ಮಾಡಿ ಒಂದು ಪಾಯಿಂಟ್ನಾಗ ಏನು ಮಾಡ್ತೀವಿ, ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಇರ್ತೀವಿ. ಆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ನ ಇನ್ನೊಂದು ಪಾಯಿಂಟಿಗೆ ತರಬೇಕಾದ್ರೆ ನಾವು ವರ್ಕ್ ಮಾಡ್ತೀವಿ. ದಟ್ ವರ್ಕ್ ಡನ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್. So the work done in moving, bringing a battery, move ಮಾಡಕತ್ತಿದೆ, just bring ಅಂದ್ರೆ ಹೊರಗಿಂದ ನಾವು ತಂದಿದ್ದೀವಿ. The work done in moving test charge from one point to another point in an electric field is called as what? Potential difference. Or the difference in potential between any 2 points in an electric field is called as potential difference. So ಅದರಲ್ಲಿ ಡೆಫಿನಿಷನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಬರಿಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ಇನ್ಫಿನಿಟಿ ಯೂಸ್ ಮಾಡು ಅಂತ ಹೇಳಿದ್ವಿ. ಐ ಹೋಪ್ ನಾವು ಯು ಅಂಡರ್ಸ್ಟುಡ್ ವೈ ದೇರ್ ಇನ್ಫಿನಿಟಿ ಆ್ಯಂಡ್ ವೈ ಹಿಯರ್ no infinity. Here there will be a finite distance because we are choosing the 2 points in an electric field only. Okay. Potential difference. PD. You can write in short P dot D. Again I write a question. What is potential difference? What is potential difference? So ಇದೇ ಏನಿರೋದಿಲ್ಲ, ಸೇಮ್ ಅಂತ ಬರ್ಕೊಂಡು ಹೋಗೋದೈತೆ. ಇನ್ಫಿನಿಟಿ ತೆಗೆದು one point to another point in an electric field. It is the work done in moving. I'll bringing ಅಂದ್ರೆ moving ಅಂದ್ರೆ moving a charge ಅಂದ್ರೆ ಬದಲು ಏನನ್ನು work. It is the work done in moving test charge from one point to another point in an electric field. In an electric field is called as is called as full impedance in an electrical device of current. It is the work done in moving test charge from infinity length only one point to another point in an electric. Okay. Symbol again V only. Formula: potential difference is equal to again work divided by charge, or potential difference is equal to V2 minus V1, or in general you can write potential difference is equal to V1 difference V2, which is greater, that we will take first. Now define potential difference. Next question. Define potential difference. It is the ratio of work done to move a charge from one point to another point in an electric field. Simply we have to remove infinity from that side, and we will write one point to another point here. So remaining SI unit same, MKS unit is also same, and define volt. Or when electric potential the potential difference is said to be 1 joule. If 1 joule of work is done in moving 1 coulomb of charge from one point to another point, from one point to another point in an electric field, then potential difference is said to be 1 volt. So this is about electric potential and potential difference. I hope you are understanding. The energy of electric charge is different at different points in an electric field. Again, dimension formula is same, nature is also same. Now we need expression to measure the potential of electric charge in an electric field. Now we will derive expression for electric potential at any point in an electric field due to an isolated point charge. Next, very important expression is this: electric potential. Expression for electric potential due to an isolated point charge in an point charge in air medium. For 5 marks, this question appeared for many times. The diagram is important. The diagram carries 1 mark, and without diagram, if you derive the equation, it will not carry any marks. Okay. So we will fix an isolated point charge. So Q. This is Q placed at O. Then it produces what? Electric field around it. This is the region of electric field. So in this electric field, I choose one of the point. This point is at P. At a distance D. The distance between these two is D. Here, how much potential is there that I want to measure. To measure the potential of electric charge at this point, we need expression. That expression we are deriving. So now, infinity. This is the direction of electric field. Now, we will choose 2 points. This is A and this is B. First I choose A. A is at a distance x from O. Here we placed what? Test charge. So, ಒಮ್ಮೆ infinity ದಿಂದ ಈ ಪಾಯಿಂಟ್ P ಗೆ ವರ್ಕ್ done ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಮಾಡಕ್ಕಾಗಿಲ್ಲ. We will calculate first small work and then with the help of integration we can calculate what? Total work. Next I choose one of the point B at a distance dx. Okay. Now I will bring this test charge from A to B. The work done is dw. And the total work done W is equal to what? Integration of dw from infinity to a point P which is at a distance D. This is a simple expression. So, ನಮಗೆ ಏನು ಮಾಡಬೇಕಾಯ್ತು ಹೇಳ್ರಿ ಈಗ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ dw ಬರೀಬೇಕು. So, work done is equal to what? Force into displacement. So, small work force, small displacement dx. So, F equation ಬರೀಬೇಕು. So, F, what is F here? Electric force. Electric force expression in ಬರೀತೀವಿ using what? Coulomb's law. So, very simple steps. First, we will write expression for F, then we will write expression for dw, and then we will write expression for W. This work done is nothing but what? Electric potential. That is the final equation. So, this is the diagram. Here, electric field and displacement, electric field and work done are in opposite direction. So, here negative work is going to run. So, this is the detailed, neat diagram. So, what is there in this diagram we will write here. O is a point in air medium. A point in air medium. Q, an isolated point charge, magnitude of an isolated point charge. P is a point at a distance D from O. Next, A is a point at a distance x from O. dx, small displacement. E, electric intensity or electric field. Okay. Now we will write expression for force. I draw these 2 points now. This is Q and this is Q0. Q is at O and Q0 at A. This distance is what? X. In between these 2 charges, electric force is there. Electric force can be written using Coulomb's law. So that is F equal to 1 divided by 4 pi epsilon naught Q1 Q2 only Q and Q0 divided by this distance x. This is expression for force. Okay. The electric force is written as is given by F equal to, don't write 9 into 10 to the power 9. So 9 into 10 to the power 9 is used only while solving the problems. 1 divided by 4 pi epsilon naught Q0 divided by x square. Now small work done. Small work done in moving Q0 from A to B. dw equal to minus F into dx. Why minus? Negative sign shows electric field and displacement are in opposite direction. Okay. We will call this as equation 1 and this as equation 2. The total one. The total work done, W equal to dw from infinity to a point P which is at a distance B. Now introduce equation 2. Infinity to d, dw is equal to minus F into dx. And what is F? Equation 1. So this is what next mathematics that you know already. Now substitute equation 1. So you write it. W minus I take out F 1 divided by 4 by epsilon naught Q0 divided by x square into dx. Take these outside. Q0 is 1 actually, or later we will write. W minus 1 divided by 4 by epsilon naught Q0 1 divided by x square into dx. Integration of 1 divided by x square into dx is minus 1 divided by, so here infinity to d, again infinity to d, 4 pi epsilon naught Q0 minus 1 divided by x. So infinity to d. Upper limit minus lower limit. Take this minus outside, minus get cancels. So work done. 1 divided by 4 by epsilon naught Q0. So 1 divided by d minus 1 divided by infinity. Anything divided by infinity is 0, that is left. Therefore W is equal to 1 divided by 4 by epsilon naught Q0 divided by this d. This is equation 3. Now according to definition. According to definition, what is electric potential? Work done to bring unit positive charge. So from 3, V equal to W is what? 1 divided by 4 by epsilon naught Q0 divided by d into this Q Q 0, they get cancels. Therefore, electric potential is 1 divided by 4 pi epsilon naught Q divided by D. This is expression for electric potential due to an isolated point charge in air medium. This is in air medium. Other than air, one divided by what is introduced here? 1 divided by 4 pi epsilon naught epsilon r Q divided by D. Or this can be written as in air medium 1 divided by 4 pi epsilon naught 9 into 10 to the power 9 Q divided by D. So here in medium 9 into 10 to the power 9 divided by epsilon r Q divided by D. This is what the expression for electric potential. Hope you understood. Just work concept is there. First year concept only, but in different way we are studying. So in the next class we will see the dependence of electric potential and electric potential due to spherical conductor and electric potential due to multiple charges, and then general expression for electric potential due to an electric dipole, and related to that concept we will study in the next class. If you have any doubts, you can comment and you can ask in the group also. I hope you are understanding. Tomorrow I will update the notes. So before I teach, you just have notes in front of you. Everyone write notes in the book. So soon the college will start. Once the college starts, I will check each and everybody's notes and even problems also. Thank you.